Good afternoon, everyone. My topic of discussion is study of four-way mixing and normal mode splitting in Kerr-nonlinear optical system containing coupled double quantum dot system. Here we explore the four-way mixing and normal mode splitting in a coupled quantum dot cavity system in the presence of Kerr-nonlinear medium. The findings presented here is valuable in the realms of sensitive detectors and quantum data processing. As we introduced that in normal mode splitting, we have discussed here is a well known example of strongly coupled system. Normal mode splitting has been demonstrated in various two-level systems, and here we explore it for the double dot system, or similarly for four-way mixing. As we can see here, the theoretical model, this is our theoretical model, and we can see that the Beer mirrors are formed the cavity, and in which double quantum dot is inserted, and with the presence of Chi3 nonlinear material. Two laser sources are inserted in between, and the system Hamiltonian we can write in this form. Method we use for this to solve this Hamiltonian Heisenberg equation of motion, we got the Langevin equations. After that, we will analytically solve the four-way mixing, and similarly for normal mode splitting by Fourier transform method. Results we can see that the figure 2a and b, we can see that for the four-way mixing signal as a function of pump probe detuning for different value of nonlinear strength, and we can see that the amplitude of the peak at detuning 0 decreases, and other two peaks decreases on the positive detuning side. For beta point 2, the process continues, and much smaller peak is observed at detuning is equal to 0 and the positive detuning side. And in the figure 2b, we can see that four-way mixing signal as a function of pump probe detuning plotted for different value of exciton dipole interaction. We note that value of coupling strength increases, the amplitude of corresponding peak resonance decreases. In figure 3, we can see that normal mode splitting spectrum of a function of frequency omega. We note that resonance peak is shifted towards higher value of frequency as we increase the value of beta. In figure 3b, we note that the value of ME decreases as the amplitude of resonance peak also decreases. This shows that at 0.5 ME, the coupling between two dots is dominant. In our conclusion, we have summarized, we have thoroughly investigated the four-way mixing and normal mode splitting in the optical system containing double quantum dots in the presence of third order nonlinear medium. And as a result, the proposal research could be useful in further research in quantum information processing and sensing applications. Thank you very much.